Welcome back, physics fans, and here we are with Physics 11. It is the traffic light problem. The traffic light problem. Okay? A car has a maximum acceleration when starting from rest of 5 meters per second squared, and when braking has a maximum negative acceleration of negative 8 meters per second squared. And the posted speed limit is 17 meters per second. And eventually we'll find out that between two traffic lights, they are 300 meters apart. What we're trying to find out is what is the shortest amount of time to go from street light to street light. Okay, so let's just follow along a couple parts here, and we'll start working on A and B and explain what we've just calculated. Okay, here we go. So what is the maximum distance that is required to accelerate the car from rest to the posted speed limit? So they're asking the distance, and what we are given is that it's starting from rest. We have the initial speed, 0. We have the acceleration, which is 5 meters per second squared, and we have the final velocity. And the final velocity is 17 meters per second. So let's just zoom in here. Given this, A, VI, and VF, and asked for T, the formula that we want to use is VF squared is equal to VI squared plus 2AD. VI is 0, so that disappears. And so VF is 17 squared is equal to 2 times 5 times D. So that's going to be 17 squared divided by 10. So D is going to be equal to 17 squared divided by that 2 and also divided by that 5. And the starting distance is, to get up to speed, 28.9 meters. This is the distance to get to the posted speed limit. It'll take them 28.9 meters to get there. Now, how much time is it required to get to that distance at that experience? So we still have the same givens, but this time we're trying to find out time. So we're still given that the acceleration is 5 meters per second squared. We have the initial speed of still 0, and we have the final speed of 17. So we're going to choose a different formula this time. We're going to choose that acceleration is VF minus VI all over T. So the acceleration is 5 is equal to VF, which is 17 minus 0 all over T. So this ends up giving us that T is equal to 17 over 5, and that is equal to 3.4 seconds. So when the light turns green, the car takes off at an acceleration of 5 meters per second squared. And to get up to this posted speed limit of 17 meters per second, it takes the car 3.4 seconds and a distance of 28.9 meters. Part B. What is the distance required to accelerate the car from the posted speed limit down to a stop? So we're now looking at the end of the trip. We're looking at the end of the thing. They're going to be coming down from the speed limit So we're asked for the distance again. We have an acceleration, and this acceleration is -8 meters per second squared. The initial speed is 17, and they're slowing down to a stop, so that is 0. So this is going to look very much like the beginning part here. We'll use the same formula because we're solving for the same unknown and plugging the numbers in, and then it'll ask for the time again, so we're doing this same part again. So we're doing A and B look very similar, just a different acceleration. So VF squared is equal to VI squared plus 2AD. This time VF is 0. VI was 17 squared. And this is plus 2, -8, and D. So our D here is going to be 17 squared all over 2 and all over 8 as well. Do you put the 17 squared to the other side or take this -16 over there? So we'll do that. We'll get 17 squared divided by the 2 and divided by the 8. And we get a stopping distance of 18.0625. Way too many significant figures, but I'm doing it. Right down to the ½ millimeter. And now how much time was it required? The time is equal to how much? So we have the acceleration is equal to -8 meters per second squared. Initial speed of 17 and a final speed of 0. So the formula that we use will be acceleration is Vf minus Vi all over t. And that will be acceleration is -8 is equal to Vf is 0 minus 17 all over t. This gives us that t is going to equal -17 over -8, which equals 2.125 seconds. So we have the time to get up to speed is 3.4, and the time to get back down to speed is 2.125. Okay. So let's just zoom in a tiny bit here to take a look at the question. If the two traffic lights are 300 meters apart, what distance must the car now travel at the posted speed limit? So we have one street light and another street light. And when the light goes green, it goes up to a speed and then stays at that speed until he has to break down to a stop there. This is very close to a velocity time graph. He starts at 0, races up to the speed at a constant acceleration, that's why it's a straight line there, and then stays at a constant speed and then constant deceleration, and this one will be a little bit steeper because that's -8 and that's +5. So we know the distance here. We know the distance here. And we know that the total distance is 300. So this distance is 28.9. And this distance is roughly 18.06. And the whole distance is 300. So 300 minus the 28.9 and also minus the 18.0625. Because this is the total distance minus the two other ones, will be the distance in between the lights. So 300 minus that number and minus that number. So the distance that he has to travel at a constant speed, the middle part C if you wanted to do that, 3.0375. Way too many sig figs. Holy smokes. But that's the distance between them. That is, once you're up to speed, the person has to travel 253 meters. How much time does it require there? Well, this is a constant velocity part. This is constant velocity, so we're going to use v equals d over t. So we have 17 is equal to 253.0375 all over t. So we can calculate t to be 253.0375 divided by 17. And that'll be the time that they have to spend. So I'll take this number and divide it by 17. That's the time they have to spend at the speed limit. 14.88. We'll leave it like that. 14.88 seconds. So I'll highlight some things here that might help you. The time for the first part was 3.4 seconds. The time for the last part was 2.1 seconds. And the time for the middle part was 14. Then let's just see, go back even further. The distance at the beginning part was 28.9, 18, and 253. So if we add these yellow ones together, we should get 300, because that's the total distance traveled. The total distance in A, the total distance in B, and the total distance in C. And the time, if we add up all these times, then we get the time for the whole trip. And the time for the whole trip will be 3.4 plus 14.88 plus 2.125. So take that number, add 3.4, and add 2.125, and we get the answer to the problem. How long does it take to go from street light to street light? Legally, not going above the speed limit and maxing out the car? 20.41 seconds. Thank you very much. Subscribe, smash that like button. Leave the comments down below. Have you clicked the like yet? You haven't left me a comment for a while, so please do that.